Okay, so today what I want to go through is part 2 of the termination. In this case, I'm going to terminate the pass-through ones. If you have not seen the video for the non-pass-through, just watch it. And hopefully you'll get a pretty good idea of how we terminate the pass-through ones. I'm going to go through the pass-through ones today, okay? So these are the pass-through connectors. I'm going to be using this crimping tool this time around, the one with the blade. So hopefully you guys will see how that one's a lot easier as compared to the non-pass-through ones. Okay, so these are the non-pass-through ones. Obviously, too much light. Let's get our boots out. Make sure we set them at the end of the cables first. So I got my boots out. I'm showing to you guys the camera. So I got my boots out. Okay, so first thing you put your boots on, right? So get your boots on your cable. Both ends, right? This time we're gonna have both ends. So we got 2. Okay, so I have both boots on the cable. So when I'm done, I can just, slip it over the RJs. We get? So as I was saying, today it's purely going to be part 2. It's going to be all about the pass-through connectors. The ones with the gaps or the holes at the end of it. See that? You can see, right? You all see, right? Okay, so you can see the gap over there. Okay, so today we're terminating the pass-through ones. Yeah, there you go. Okay, so let's grab 2 of them since we got 2 ends. And then what's the first 2 we grab? Our stripper, right? So the first 2 we grab is our stripper because we want to remove the jacket off, right? So you grab the strippers, and what do? You fix it on it, right? And then 360, release, and then you got your jacket out. Okay, so in part 1, what we did was I terminated using the standard B, right? This time I'm going to use standard A. So I show you the different colors, the difference, the color codings. With standard B, it was orange. Sorry, it was light orange or white orange, right? Followed by orange. What else? White green, followed by what? Solid blue, white blue. What else? And then a green, right? And then you do have your white brown and then your solid brown. Okay? So based on this, yeah, but you guys call it network cables. The technical name is Ethernet cable. Okay, But for the most part, people just call it what? A network cable. But you have to understand that a fiber optic is what? A network cable too, right? Right? A telephone line is what? A network cable too. If you want to be more specific, is Ethernet. E-T-H-E-R-N-E-T. Ethernet. That's the correct technical name for it. Everybody just says network cable, network cable. Which is technically wrong, right? Okay. So I'm going by this standard this time around. Now on part one, we went by this, which was the white orange, followed by orange, and then you have white green, followed by solid blue, white blue, solid green, white brown, and then solid brown. But for this time around, we're gonna go with standard A termination. So you guys, so just make sure you note them down. So the assignments or quizzes, like you know what the orders are. And you can always Google them. It's always on the internet, plenty of them. But tonight, also this afternoon, we're gonna go with standard A. And the color codes in this particular standard is just you swap the oranges with the greens from standard B. So you all just swapping them around. So wherever you find a white, green, you replace what? A white what? Orange instead. Sorry, green instead. Right? Wherever you find a white, orange, you replace it with a white, green instead. So it means that the first pin one has to have what? White, orange. Sorry, white, green instead. Because in standard B was what? White, orange. Right? So in this standard A, we're going to replace the oranges with the greens. So you're going to have the white, green starting, followed by green. And then you're going to have what? A white, orange now. Because we're replacing the oranges with the greens in terms of the order and the pinholes. Yep. So white, orange, and then you go with your blue, your white, blue, and then you bring back your orange, your solid orange, and then you basically remain. You have the same brown, white, brown, and brown at the end of it. So you don't change the blues and then the browns in both standards. It's only the oranges and then the greens that you swap around. Okay, so if you want to get the standard B part, the color code correctly, all that you're doing is replacing the oranges with the greens where they're supposed to be at. So if you start with standard B with orange, white, orange, in A will be what? White, green instead. Are we good? So you just swapping them around, that's all. For just those two colors. The rest remain wherever they were on their respective pinholes. Okay, so for blue and brown, they stay at their pinholes. They don't move around. Are we good? Okay. Great. So now that I have my one end of my Ethernet cable stripped, let me strip the other end as well. And then let's separate the color codes and cut out some of these strength members or the dividers and the rope that you have in there. Okay, so pay attention. Standard A, right? We're replacing the what? Oranges with what? The greens. So we're going to start with what? White, green first. So I got my white, green over here as the first pin, pin 1. white green, followed by what? Solid green. And make sure you keep them in straight order. And then we will introduce the what? The white orange this time around, right? On the third pane. So white orange now. And you maintain the blues. So the blues still remain where they are. So you got solid blue. On pin 4, white blue, pin 5. And then you bring back your what? Your orange, solid orange. A bit out of focus, but you can hear what I'm saying. And then the browns, right? So you have your white brown, which is pin what? 7. And then finally pin 8, you have your solid brown. Okay, so we got them in the right order. Nicely ordered up. Make sure you keep your thumb on them all the time. Otherwise, if you release them, I guarantee you it will just flicker all over the place. Start all over again. So keep your thumbs on them all the time, where the position, so you don't miss them. Let me see, I think I got this. Rearrange this properly. White, blue. Your orange. White, brown, and brown itself. Okay, so you want to keep them together really nice and tight. I see some of the cables are trying to move around. Okay, so now the beauty of the pass-through is that you don't have to worry about the length now because it's going to cut off automatically at the end, right? What you need is just an even end. I'm just going to stick it over here. And then I pick my pass-through with the clip facing downwards. So I can have my pin 1 starts on my left and pin 8 on my right. And then you just work your way through it. And watch how the pins come out. See that? The pins are out now. The wires are out now. They're hanging out. See, that's the easy part about using the pass-through. So the wires have gotten through their respective pinholes and now showing up at the end or at the front end of the RJ. So with this, at every given point in your termination, you will always get the color codes correctly because you can see them now. You have your white green, solid green, white orange, solid brown, white brown, solid orange, white brown, and solid brown. Okay? So that's the beauty of the pass-through. You see that at the end. Now there's no more double crimping because now you know you got the correct you're always going to get the color codes wires in your respective pinholes. But with a non-pass-through, you can't see them at the front end of the RJ. You can only see inside it. And sometimes if you're not careful and you crimp it, you don't realize that you screwed up the color codes because you couldn't see them very well. And with this, the outside, and you can clearly see them. Are we good? I usually say to my students that this should have been the best option to start out with the RJ terminations. But unfortunately, everybody started with the non-pass-through, right? And there's a reason why when engineers first start terminating network cables, they didn't think about pass-through. It was all about let's get the wires into their respective pinholes and then terminate them. Now, over time, after so many years, they realized with the non-pass-through, people were taking so much time to terminate the wire because sometimes they realized that their first screen ended up with the wrong color codes in their words, different pinholes. That's taking time off the termination process. And when time is money, you start thinking twice about some of these things, right? But by then, they've already come up with so many of these pass-through terminations and crimping tools. So non-pass-through connectors and crimping tools. So many of them. So it was after they realized that this was taking too much time and was giving network engineers so much headache that they went back to the drawing board and then redesigned it to have what? A pass-through. We good? To save what? Time and what? Money. Because with this, you always get it correctly. Always. Because you can see the wires at the end to make sure that your color codes are in what? The right order. We get? You can always see it. But with the non-pass-through, you can't see it. We get? The other catch to the pass-through is that you have to pay a lot more money. Non-pass-through RJs, a single one will cost you $2. 2 times 8 is what? 16 Ghana cedis, right? Right, guys? Pass-through, it's 1 cedi or 2 cedi maximum. So you see the difference? Pass-through 2 cedis. Sorry, non-pass-through 2 cedis. Pass-through, you have what? 16 cedis. Simply because what? They're saving you what? Time and money. And on top of that, the crimping tool costs a lot more money as well. This here is $55. This is $35. So huge difference, huh? Okay, so now that we got that, let's just insert it into our RJ45 port over here or interface over here, and then see how well the blade cuts off the ends. So now you see that? You look at it, it protrudes out. Now if I just crimp on it, watch. Now let me just this way, so you can see cut it off. Is that good? Oops. Okay, so I'm gonna just see that it's cutting off. See, nicely even up. And you done. See how easy that was? A lot easier than with this guy's, right? Okay, so the same thing over here as well. Let's just separate it up. So tell me the color codes. We are using A. We terminate in a straight through cable. So tell me what the color codes are. Say, I can hear you. You don't talk. Let me there. When it comes to assessment, then you start thinking through, right? There you go. So you have white, orange now. Solid blue, there you go. And white, blue. Solid orange, there you go. White, brown. Okay, guys. I'm glad some of you are catching on very well. Some of you are just goofing up in the back, watching porn, huh? Yeah, because the class is so damn boring. Okay, so we got so we got them in the nicely, ordered manner. Just got an even cut over here at the end. And then grab your RJ with a clip facing downwards. Say it again. All the connectors for the Ethernet cable termination are called RJ45s. But they just have two types, a pass-through and non-pass-through. Pass through, it's passing through, pass through. And then you grab your crimping tool. Make sure you line up the clip with the respective port or gap or whatever you want to call it. And then just crimp on it as usual. Watch it cut it off nicely and even. And then once you're done, you just slip off your boot covers or your clip covers or your connector covers, technically called boots. You basically just move it over and then get it covered up. The boot. How do you spell boot? B-B-O-T, B-O-O-T, sorry. A boot, So you just move your boots over. And it's right there. You got a nicely terminated patch cable. Like a professional, huh? So with this, we don't even have to worry about testing it because we know it works. It's right on, right? So it's on point, right? There's no point terminating anymore. Or sorry, testing anymore. Because you know for a fact that you get the right orders. The right pins in their respective holes, right? Or the wires in their respective what? Pinholes. Okay, but if you just want to be on the safer side, plug it into your what? Your tester. Power it on. And then step right through them. So you have pin one and one corresponding, right? On both ends. Pin two, pin two. Can y'all see? Can everybody see? Yeah, but then we say no, no, no. And then go through it. So we got 3, 3 aligned, 4, 4 aligned. Add up. Much better now. So natural light, huh? So 7, 8, and then your ground. Auto. So for the remotes, so 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And then your 8th pin in your ground. So once you got this, like I said, there was no need for testing anymore. With the pass-through, there's no point trying to test it because you can see what you did. You know you nailed it. Yeah. This is the remote tester, and this is the transmitter tester. They are all testers, but this is the remote device. So it tells me you've not watched the video. And students, huh? It's pretty obvious you've not watched the video. So this is your transmitter, and this will be your remote receiving device. Okay. All right, so we got a nicely terminated Ethernet cable, and it's pretty much good to go. Okay. So I have a question over here. Somebody is saying, so does that mean that these color codes, green, white, green, orange, white, blue, blue, those are correct. Who said it? Who's this guy here? Morty. That's you right there, right? That's for standard A. Correct. Yeah, so this was a standard A straight through cable that we terminated. In that video, I did standard B straight through. Okay? And when you mismatch, then what do you have? When you mismatch the color code, sorry, the termination standard, what do you have? When you mismatch the standard on both ends, what do you have? A crossover. You can hear me not say the word. You get a crossover. And then when I give you assessments, I don't know, they get like zeros and all the on the assessment for me. Okay, guys, so that should be it for the hash determination.